An unstable radioactive nucleus breaks down by emitting radiation, which is called radioactive decay. We can show these radioactive decay processes using equations. In a nuclear equation, the radioactive nucleus is shown on the left, while the resulting nucleus and the emitting radiation is written on the right side. The sum of the mass numbers and the atomic numbers on the left should be equal to the sum of mass numbers and atomic numbers on the right side. In other words, the nuclear equation should be balanced in their mass numbers and atomic numbers. Let us look at alpha decay. When a nucleus emits an alpha particle, its mass number decreases by 4 and the atomic number decreases by 2. The resulting nucleus is now a new element. When uranium-238 with an atomic number 92 decays by alpha radiation, it ends up as thorium-234 with an atomic number of 90. When americium-241 decays by alpha radiation, let us figure out what the new element formed is. It ends up with a mass number of 237 and an atomic number of 93. So you're going to look up in the periodic table, look for the element with an atomic number 93. And you will find that the element formed is neptunium. Polonium-214 with an atomic number 84 undergoes some radiation, ends up as lead-210 with an atomic number of 82. So to figure out which type of radiation is emitted, we're going to subtract or find the difference between the mass numbers and the atomic numbers, and we come up with alpha radiation. In beta radiation, a neutron in the radioactive element breaks down into a proton and an electron. The proton stays in the nucleus while the electron is emitted, which is the beta decay process. The resulting nucleus will have one more proton. So the atomic number will increase by 1. By emitting a beta particle which has no mass, the mass number of the new nucleus formed will not change. In the radioactive decay of carbon-14 by beta radiation, the resulting nucleus will have an atomic number of 7, which is nitrogen. The mass number stays the same at 14. When yttrium-90 with an atomic number of 39 undergoes beta radiation, what is the resulting nucleus? We're going to add one more proton to the atomic number. It becomes 40, resulting in the zirconium nucleus. The mass number is still 90. When chromium-51 undergoes some type of radiation and resulting in a new nucleus with the same mass number but with an atomic number of 1 unit higher, we figure that the type of radiation emitted was beta. Gamma particles have no mass or charge. So in gamma radiation, the resulting nucleus will not change in mass or the atomic number. Rather, it will have less energy. The most common gamma emitter is the metastable technetium-99. When decayed by gamma emission, it ends in more stable technetium-99. Barium 137 decays by gamma radiation. What is the resulting nucleus? The resulting nucleus is still barium with the same atomic number and mass number. Cobalt 60 emits some radiation, results in cobalt 60 with the same atomic number. What is the type of radiation emitted? The type of radiation that results in the same atomic number and mass number. So no change in the nucleus except with less energy is gamma emission.